Hello, this is Mrs. Huntley. We are in the supplemental packet that comes in Module 7, and you should be on page 5 of your supplemental packet. Your essential question is, how do I turn fractions into decimals and decimals into fractions? What I'd like you to do on this note page is kind of divide it in half. Because I don't want you to go more than the halfway point taking your notes on long division, because we have some notes about turning a repeating decimal into a fraction that you're going to want to make sure that you have space for, because there's not space in the handouts. So quick review of long division. We're actually going to do the first problem that's on page 6, 3/8. So if you have a fraction, like 3/8, this is your numerator, the 3 being divided by 8. So if I'm making it a long division, because again, we're not supposed to use our calculators for this, the 3 goes inside, the 8 is on the outside. Now 8 doesn't go into 3 at all. So we could put a 0 up there, and 8 times 0 is 0. We don't have to do the multiplication here, but what we do have to do is create a number that 8 can go into. And hopefully you remember, when you add a decimal and you add a 0 past the decimal, you're not changing the value of the number at all. 3.0 is the same as 3. So 8 does go into 30. How many times does 8 go into 30? Hopefully you know your multiplication facts enough to know that 8 is going to go into 30 3 times. 8 times 3 is going to be 24. So I'm going to put the 24 down there. I'm going to draw a line and I'm going to subtract to find my difference there. So 30 minus 24 is 6. I'm not done yet because I have a remainder. So I'm going to add another 0 here, and I can bring that 0 down. And 8 goes into 60. How many times would 8 go into 60? It's going to be 7. 7 times 8 is 56. And again, I'm going to subtract these two. 60 minus 56. Add another 0. Bring it down. 8 goes into 40. 5 times. And there is no remainder. So I know I'm done. So if I'm turning the fraction 3/8 into a decimal, I'm going to do this division, and 3/8 is the 3/8 is the decimal 0.375. Now you might be saying to yourself, how do I know when I'm done dividing? How do I know when I can be done adding zeros and bringing them down? In this instance, we had a remainder of 0, so we knew that it was going to be a terminating decimal. What if we have a repeating decimal? We're going to do another example real quick. If I have 4/9, that means 4 goes inside the house and 9 is on the outside. Now don't get this confused, the division bracket, don't get that confused with our square root sign, with a radical sign. The radical sign, and don't write this down, the radical sign has that little hook thing on it, and then we can put a number in here if it's going to be a cube root, whereas the division symbol is just like a half of a rectangle. So how many times does 9 go into 40? That would be 0. Whoop, it helps when you change back to a marker. How many times does 9 go into 4? That would be 0, so I'm going to add a decimal. How many times does 9 go into 40? That's going to be 4, and that's going to be a 36. 40 minus 36 is 4. So if I add a 0, I'm all of a sudden caught in a loop here, where my 4 is going to keep repeating. So as soon as I see a number here that's the same number as here, I know I'm stuck in a loop. So I can say that 4/9 is equal to 0.4 repeating, because every time I do it, I'm going to get the same answer. Now there's also another way to look at this. in both instances. So let's take a look at 3/8 first. I'm going to change colors real quick. 3/8. If you look at my denominator, my 8, if I can write my denominator as a product of 2's or a product of 5's, I know it's going to be a terminating decimal. In other words, if I can break this down into prime factors, which I can, so I've got 2 and 4, and then I've got 2 and 2. So this is a product of 2's. I know it's going to be a terminating decimal. Whereas my 4/9, this is not going to break down into 2's. It's going to break down into 3's. Anything other than 2's and 5's for my denominator, they're going to be repeating decimals. If it breaks down into, if my prime factorization of my denominator breaks down to 2's, products of 2's or products of 5's, I know it's going to be a terminating decimal. So let's move on to the next page, because I don't want to do all of the examples on your note pages. I just wanted to give you those 2 examples with a little bit more space. So your handout, we know that values can be represented in several ways. For example, a fraction can also be represented as a decimal or vice versa, which means the opposite is also true. If a fraction converts to a decimal that we eventually stops, we call it a terminating decimal. Otherwise, if a fraction converts to a decimal with a repeating block, we call it a, you guessed it, repeating decimal. Okay, so 3/8 we did already. You don't have to show your work on this one. You can just rewrite the answer unless you want the practice of practicing out some division. Either way is fine. This is point, okay, marker helps. This is equal to 0.375, and it's a terminating decimal. I said 0.375, so that's fine either way. The next one, 1/16. First of all, let's take a look at the 16 real quick. Can I rewrite 16 as a product of 2's so I know whether this is going to be a terminating decimal or a repeating decimal? Let's see, 16. I'm just going to do this really quick. That's going to be 2 and 8. 8 is going to be 2 and 4. 4 is going to be 2 and 2. So yes, I'm saying right now that I believe this is going to be a terminating decimal. Eventually, in my division, it's going to come to an end. So let's take a look at how I would do this. 1 goes in here, 16 comes out here. The denominator goes on the outside. How many times does 16 go into 1? That would be 0. Add my decimal, add my decimal. I can add a 0 now. How many times does 16 go into 10? Again, 0. So I'm going to add another 0 here. How many times does 16 go into 100? Let me think about this, because again, I'm not supposed to be using my calculator right now. So let me think about multiples of 20. So if I'm trying to get 20 to go into 100, let's see, 20, 40, 60, 80, 1. It would be 5 multiples of 20 going into 100, but 16 is less than 20. So do I think it's going to be 5 or do I think it's going to be 6? I could guess and check. I could start with 5 and see what happens with it. Let's see, 16 times 5. If I put 5 up here, don't write this down. I'm just telling you right now, don't write it down. 5 times 6 is 30, so 0, carry the 3. 5 times 1 is 5 plus 3 is 8, so that's 80. That's a 20 difference between, that's more than 16, so I know I have another group of 16 in there. So I'm going to erase that, and I'm going to come back. This is just how I would attack the problem if I didn't already know the answer, which is why I told you not to write this part down, because I didn't want you to have to erase if you were tracking that closely with me. So we're going to bump up 1 to 6. So now I take this 6 times 6, that's 36. So I'm going to write my 6 down in the ones column here, carry my 3. 6 times 1 is 6, plus 3 is 9. So 6 times 16 is going to be 96. 100 minus 96 is 4. Add another 0. Bring it down. How many times does 16 go into 40? Let's see, 16 times 2 is 32, so let's go with 2. 32. 40 minus 32 is 8. 0. How many times does 16 go into 80? Hey, we already did that math, and it turned out to be 5. 5 times 6 is 30. Carry the 3. 5 times 1 is 5, plus 3 is 80. And then you have a remainder of 0. So 1/16 is equal to 0.0625. Really small decimal. What I'd like you to do right now is take a look at number 3 and see if you can figure out if this is a repeating decimal or a terminating decimal, first of all. Is this going to be one that repeats on and on? Can we write our 6 as a product of 2's? So let's break down 6. Let's see, 2 times 3. Oh, no, we can't, can we? So I'm gonna predict right now that this is going to be a repeating decimal. Going to set up my division. 5 in here, 6 out here. How many times can 6 fit into 5? 0. See if you can take it from here. So go ahead and pause the video. See if you can finish this division. Don't cheat, please. Don't use a calculator. See if you can do it with long division, and then come back and check your answer. Okay, so how'd you do? Did you come up with 0.833? And did you notice that you're in a loop here? As many zeros as you add, you're still going to get 20, and that 3 is just going to keep repeating on and on and on for as many times as you do it. So the way you would write that, 5/6 is equal to 0.83 with that bar only over the 3. You only put the bar over the part that repeats. I would not put the bar over both 8 and 3. I want it just over the 3. Okay. 4/9 we did already. It was on the other page, and we said it was repeating. I should have said that this one was terminating, because we were supposed to say if they were terminating or repeating. So this one we know is repeating. And we knew it was 0.4 repeating. Okay, I don't want our video to go too long. I promised you I was going to keep it to less than 15 minutes. So what I would like you to do is see if you can go ahead and set up 5 and 6. First of all, see if you can figure out, well, this one's kind of easy. 4, can I write that as a product of 2's? I'm thinking. So we know right now it's going to be a terminating decimal. See if you can set it up in a long division, and see if you can do the same thing with 6, and then we will check our work when we come together on Monday. And then our video on Monday night will be turning decimals into fractions. So we're going to break this particular lesson up into 2 days. Okay, so I hope you have a great weekend, and I will see you on Monday. Bye.